Next, we are going to discuss fifth unit. The first topic in fifth unit is functions. First, we will see definition of function. A function is a self-contained block or a subprogram of one or more statements that performs a special task when it is called. What is the need for functions? There are quite good number of needs that are available. First, we want to perform a particular task repeatedly. For example, you have a set of statements that you will be using repeatedly for some particular purpose. Then you can just pull that particular block and make it as a function, so that each and every time you want to execute that particular set of statements, then you can call the function name. Next need is the large program can be reduced to smaller one, that the number of lines will be reduced, which eases our debugging facility and readability. Next, we will see how we need to declare function. First, you need to give function name. Function name should be followed by parameter list. Then that will be followed by argument declarations. Inside the function, that is after giving function name and parameter, you need to give open curly braces, and inside that first you need to give the local variable declaration, and that will be followed by all the other statements. Then you need to give return value, that is the value that you need to return to the calling function. Now we will see how the function works. Here you can just see I have a predefined function main, and inside I have called one function name as ABC, and that has having three parameters x, y, z, and these are all called actual arguments. That is a function which is calling and another function, and the parameters that are available in this particular list with this particular calling statement. Okay, we call this as actual argument, and the one which is called function, the parameter list is called formal arguments. And you can just see the function definition is available here, as we discussed in the previous slide. What we have, the function declaration definition. There are two things. One is function declaration, second one is function definition. The function definition should have the block or set of statements which will accomplish a special task, as we discussed earlier, and it should have a return value, because the calling function will require some value for processing. Sometimes what we'll be doing, the function will not return any value to the calling function. Instead, whatever operation that it want to perform, that will be performed in the function itself, and it will just return the control. Now we will see working of function. We have, these are the parameters as we had discussed previously: actual arguments, formal arguments, function name, argument and parameter list, and function call. These are the explanation required for a function. First we will see what is actual arguments. The actual arguments are arguments of calling function. Next, formal arguments, the arguments of called function are called formal arguments. Next, function name. We have used we have assigned names for variables, constants, and other tokens. Similarly, function name is also follows the rules which we have followed for variable naming. Next, argument or parameter list. So the function name followed by a parenthesis, and inside which we will be giving some variables. Those variables are called parameter list or arguments. Then we need to know what is a function call. A compiler executes the function when a semicolon is followed by the function name. So there is a major difference between the function definition and function call. When a function call, okay, you will be giving function name followed by a parameter list and the semicolon is used to terminate. Then the compiler will detect this is the function call. At the same time, when you just see the function definition, the function name parameter list, but it won't have a semicolon, instead it will be having open curly braces, and you will be having the body of the function and you will be having close curly braces. So this is how the compiler will detect. So this is the place where I need to call the function, and it will search the function and the function will be executed. These two slides which we have discussed will explain how the function actually works. This is example of a function. You can just see double power, open parenthesis, and you have two parameters. One is of type double, next one is signed, and the name you can give any name. And you can just say inside the function name I have declared one variable ret value, which I am going to use for returning, and next I am using one more value, unsigned int I, and here I am using the a particular for control structure to multiply these two things, and for I is equal to 1 and I less than equal to power I plus plus return value is equal to, so it will be multiplying that particular number of times and it will be returning the return value. You can just see the return value is initially 1.0, and I am assigning, for the first time I am assigning the value, and that is multiplied by that particular value, and this will be stored in the return value itself, and finally you are returning the return value, and this will be returned to the calling function. This is a simple example for functions. Next, scope of function variable. So the local variables have a limit. Its visibility is available till the close curly braces of that particular function, but sometimes we want to use some variables whose visibility should be available for the whole program, and that is all functions that are available in the particular program should be able to access these variables. These variables are called global variables. And next is your local variable. Local variable visibility, as I said earlier, it will be available only for that particular function alone. You cannot just access from any other function. Next, you have a static variable. Okay, this static variable have a special type. It will not initialized one and again. Suppose if you are declaring a variable as static variable, it will be initialized only once. Next, you can just see global variable don't tie on return from a function, but local variable it will die. Okay, the local variables, as I said, scope is limited till close curly braces, so the visibilities will not available for the other functions. Next, it's very important thing, recursive function, an important feature which is available in your C programming. Recursive function. What is recursive function? A function that calls itself is recursive function. And I have given some uses of recursive functions. It is used for calculating factorial, Fibonacci series, and the tree calculation, especially when we discuss something about data structure. This recursion function helps a lot. But there are some disadvantages also available in your recursive function. It will occupy more memory compared to non-recursive functions. This is example for recursive function. I use the Fibonacci series for calculating Fibonacci series, I used recursive function. Without using recursive function also you can do it, but recursive function, with recursive function, how it performs. This is a simple example. You can just see here you can just see I am calling in the return statement fib num minus 1 plus fib num minus 2. So continuously it will be calling. When it comes 0 or 1, it will automatically terminate. Okay, each and every time the value will be stored in stack and it will be popped in and pushed in, popped out, and all the operations will be performed, and it will be returning the value to the calling function. The next topic that we are going to discuss is arrays. Definition of array. Arrays are collection of similar data types. A set of similar data types. The C language provides a capability that enables the user to define set or order data items known as array. These arrays, they have these collection of order data will have similar data type. It might be integer, float, or character. The character array is generally called as string, which we have used in. What is the need for array? It is to store sequence of similar values and to index the collection, to reduce number of unique variables that you use in our program. Suppose if you are going to store 10 values like as 10 grades of 10 different students, then for each and everything we will be giving one unique variable. Instead, if you just give array name and with different index, then it is easy for us to store the values and to retrieve values. Even for searching it is possible, and to perform operations like sorting, searching over the collection. These are the needs for arrays. Next we are going to see how we are declaring arrays. Like any other variable, array must be declared before they are used. The general form of declaration is like this. First you need to give the data type, that will be followed by the variable name, and you need to give inside the square bracket the size of the array. Initially, when this declaration statement executed by compiler, the space, for example, if you are giving int I of 10, what is the size of integer which we have discussed? It is 2 bytes. Then 20 bytes consecutive memory will be allocated for your array I, and these are reserved during declaration and during processing. That is when you work with arrays, okay, the values will be stored and it will be updated, all the operations that you can perform using this particular memory space which is allocated during the declaration phase of your program. Now how we are going to use an array? For example, each array we are declaring a particular array int grade of 50, and you want to access a particular value which is stored in an array. You can just use it. Suppose you want to get or you want to obtain some value which is available in 50th location of grade array. Okay, the 50 is the subscript or index, whatever you can just say. So that particular value will be stored in the variable g, but g should have the same data type as that of array. Otherwise the internal typecasting will be performed if it is possible, otherwise it won't accept. Next you can just see, you can also assign value to particular location. For example, you are assigning marks grade as 95 for grades of grade of 30, that is the 30th student have obtained mark of 95, then you can just use like this. Then there is one important point, the array index starts from 0, not from 1. So if you are saying grades of 30, then you are storing 31st value in it. So this is very, very important point. The array index starts from 0. So here I have just used one control structure to get the sum. This is one statistical operation where you will be having sum of a particular sequence. So here in this particular sequence I will be adding 50 different values and I will be obtaining sum. Initially the sum will be initialized to 0 and the for loop will be executed each and every iteration. The new unique value will be added to the sum and we will be getting new sum in every iteration. At the end we will be displaying the sum of the 50 marks, 50 different marks. We will just see how we are going to initialize an array. So this is also possible. Variable initialization we have seen. Here we are going to see initializing array. The general form will be like this: type, first you need to give the data type and that will be followed by the array name and size, and you need to give equal to, then that will be followed by in open curly braces. In open curly braces you need to give the list of values separated by commas. and in the bottom you can just see the example int number of 3 which is equal to 0, 0, 0. So number of 0 is 1, number of 1 is 0, number of 2 is also 0. So all these things will be initialized to 0. So always we won't be using single dimensional array. There are quite good number of situations where we need to use multi-dimensional array, like matrix, tables. We need to use multi-dimensional array, and here there is a general form. First you need to specify the data type, and that will be followed by the array name, and that will be followed by row size and column size if it is a two-dimensional array, and the bottom line you can just see the example. Okay, so here 0 to, if you are giving int m of 10 of 20, then you have two-dimensional array and it should be end with a semicolon, and you will be having 0 to 9 rows and 0 to 19 columns. The first element will be stored in 0, 0, and the last element will be stored in 9, 19. This is how the multi-dimensional array will be declared and used. Now we will see initialization of multi-dimensional array. There are two forms. The first form is like this. Suppose you have two-dimensional array, the first row will be given like this, that is in a open curly braces. First you need to give 0, 0, 0, and without a comma you need to start the second row. Okay, this is one particular form where you can initialize the multi-dimensional array. The other form, which will avoid the confusion, what we will be doing, the first row will be again enclosed in one curly braces and the second row will be enclosed in another curly braces. This is how you will be initializing multi-dimensional array. And very good applications of your multi-dimensional array is, that is your two-dimensional array in specific, is matrix addition, matrix multiplication, and the tables. You will be forming multiplication tables now. For all these things you will be using this two-dimensional array. And single dimensional array you will be using it to store the sequence of that is your classes name list and grade list and the other things. And you can also perform operations like sorting, searching, and other related operations which will be performed, like sum, average. All these things requires all the operations that are available in an array. Next is structures in C. A structure definition. A structure is a collection of variables and a single name. The variables can be different type. See, the array is one data type, or you can just say this is data type, which is a collection of similar type. But here structure is a user defined data type, which is collection of different data types. We are going to see how the structure is declared, an example for a structure. Defining a structure type is usually defined near to start of file using typedef statement. The typedef statement will assign a new name for this particular structure, and that will be user defined data type, which will generally occur after hash define or hash include statement in a file. Here I have given one example: typedef struct open parenthesis char name, and you can just see I have just given character array for the first one for name, and similarly for the next one I have given course, which is also character array. That is followed by two integral data types, one is age and next one is year, that I have given structure name as student. Now this will create a new data type, and we are going to see how we are going to use it. We will be declaring a variable for this structure similar to declaring integer or float. You can just see the second line. I have declared a variable for this structure data type. Structure is an user defined data type I have declared. Now we are going to see how we are going to access the members inside the function. You will be either using the dot operator or the insertion operator depending upon the declaration of the variable. Suppose if you are using a reference variable, then you can go for insertion operator. Otherwise, if you are declaring in the in this particular way, okay, student st underscore rec instead of using reference, okay, then you will be accessing the dot operator. So I said, if you have pointer for a structure, there is the reference variable, then you need to use this insertion operator, and you can just access name and the other data members which are required. Those variables that are available in your structure are called data members. So one important feature which your function will return value, but the return statement will not allow you to return more than one value. But there are quite good number of situations where we need to send multiple values to the calling function. In that particular case, you can use the structure as your return variable, which will carry the collection, that is the data members of the structure along with the structure variable name. So this is how we will be able to send more than one values using your return statement. If you are not using structure, then definitely it is not possible for us to send more than one value to the calling function, and we will be assigning a pointer, that is the structure variable. Here it will be considered as pointer, and it refers the data members. Using the variables, it is possible for us to access all the members. Next is another important topic, pointers in C. So the pointers, why we are having a pointer? A variable will have some value. Suppose you want to have one more reference to the variable name, then you can use pointers. In general, pointers will point a value for which it has been declared. For example, if you declare something like this, int star pi, the int star pi is the declaration statement. So it clearly shows you have declared an pointer that points an integer value, and you have already declared a particular variable I. You are going to assign the address of I to this particular pointer. So instead of using I, you can use the pointer variable pi, which will obtain the value from this. Here the ampersand symbol will return the address. Here the ampersand symbol will give the address, and this pointer will store that particular address. If we call the value, then the value that is available in this particular address will be returned. Int star is the notation for a pointer to point an integer. Ampersand is the operator which returns the address of its argument. When you use ampersand I, we call it as reference. I already said the variable, you will be using one more reference for the variable name. Okay. The opposite operator which gives the value, is asterisk symbol. Example, I is equal to star p. So the pi is the variable which is pointing the variable I. So if you want to have the value, then you need to give star pi. And this, you need to note a point, the star symbol which you are using with the multiplication, you should not confuse that with this particular value operator. Here we will be using for value operator, but that is totally different from this. That is, the multiplication operation is totally different from this one.
Learn about pointers? Oh, goody!
Well, to get started, I guess we're going to need a couple pointers.
Okay, this code allocates 2 pointers which can point to integers.
Okay, well, I see the 2 pointers, but they don't seem to be pointing to anything.
That's right. Initially, pointers don't point to anything. The things they point to are called pointees, and setting them up's a separate step.
Oh, right. I knew that. The pointees are separate. So, how do you allocate a pointee?
Okay, well, this code allocates a new integer pointee, and this part sets x to point to it.
Hey, that looks better. So make it do something.
Okay, I'll dereference the pointer x to store the number 42 into its pointee. For this trick, I'll need my magic wand of dereferencing.
Your magic wand of dereferencing? That's great.
This is what the code looks like. I'll just set up the number and...
Hey, look, there it goes. So doing a dereference on x follows the arrow to access its pointee, in this case to store 42 in there. Hey, try using it to store the number 13 through the other pointer, y.
Okay, I'll just go over here to y and get the number 13 set up, and then take the wand of dereferencing and just... Oh!
Oh, hey, that didn't work. Say, Binky, I don't think dereferencing y is a good idea, because, setting up the pointee is a separate step, and I don't think we ever did it.
Good point.
Yeah, we allocated the pointer y, but we never set it to point to a pointee.
Very observant.
Hey, you're looking good there, Binky. Can you fix it so that y points to the same pointee as x?
Sure, I'll use my magic wand of pointer assignment.
Is that going to be a problem like before?
No, this doesn't touch the pointees. It just changes one pointer to point to the same thing as another.
Oh, I see. Now y points to the same place as x. So wait, now y is fixed. It has a pointee. So you can try the wand of dereferencing again to send the 13 over.
Okay, here goes.
Hey, look at that. Now dereferencing works on y. And because the pointers are sharing that one pointee, they both see the 13.
Yeah, sharing, whatever. So are we going to switch places now?
Oh, look, we're out of time.
But
just remember the 3 pointer rules. Number 1, the basic structure is that you have a pointer, and it points over to a pointee. But the pointer and pointee are separate, and the common error is to set up a pointer, but to forget to give it a pointee. Number 2, pointer dereferencing starts at the pointer and follows its arrow over to access its pointee. As we all know, this only works if there is a pointee, which kind of gets back to rule number 1. Number 3, pointer assignment takes one pointer and changes it to point to the same pointee as another pointer. So after the assignment, the 2 pointers will point to the same pointee. Sometimes that's called